what were some of the factors, okay, nicely, raise your hand, what were some of the factors that maybe the pyramid did not get a high score? Okay, what's it, what? Size of the pyramid, Panchito?
The material it was made out of.
The material it was made out of, Lino?
The land.
The land?
The amount of people working on it.
The amount of people that worked on it, right? So there's many factors, right? What determine the quality of the pyramid, right? So today you're gonna listen to a video and you're gonna respond to questions about how the pyramids of ancient Egypt were built. And you're gonna participate in a discussion. So some of these we're gonna do together. And I expect you to participate, and I'll tell you how you're going to participate, okay? So be ready to participate. You guys really have to listen carefully to the video, okay? Listen carefully if I have to. So this is an interactive video, which means it will stop and let you respond to the question, okay? Right? So please. I'm gonna wait till everyone's quiet. No one should be talking right now. I hear talking from that side.
Game theory. I can't see.
Okay. Jalen. Here we go.
Hey smart people, so a few weeks ago we made a video about the pyramids and how, while they are pretty heckin' impressive, we can trace the evolution of their construction and see the ancient Egyptians using trial and error and making a few mistakes, which basically tell us they didn't need aliens to build them, they just needed science. You guys really liked that video, but a few of you were a little bothered that despite the fact it was called Who Built the Pyramids, I didn't talk about how the pyramids were made. So, let's talk about it.
Alright, so give me a smart sentence or two. You guys know what a smart sentence is, okay? So a smart sentence is something simple, something we've learned. I'm still here talking. It hasn't stopped. Something simple, something smart, something that you've learned in class, okay? It could be one sentence, it could be two, so write it down. Oh, you have a question? You're gonna give an answer? Not yet, question number 3. Right. So whatever you've learned in class, okay, that you know about ancient Egyptian pyramids, we know a lot. Maybe you could tell me one of the reasons why they were built, why they were, you could tell me what they were used for, okay? Okay, so just some of the things that we've talked about in class, from the lessons we've had on Nearpod, or the examples that I've given you. Okay, we're gonna move on.
The 100+ pyramids scattered around Egypt were all built a bit differently, but we're going to focus on the big one. Let's review the stats. The Great Pyramid originally wrote.
Did you guys know there were about 100 pyramids?
Yeah.
The ones that we're gonna focus on. Okay, I'm gonna wait. Get up and come and sit over here. With your things. Alright, here we go.
Rose more than 146 meters tall and contains about 2.3 million stone blocks. The start of any construction project truly begins with the foundation, which is impressive in its own right. Its base is leveled less than 2 centimeters, squared within 11, and its edges are aligned to the compass within 3/60ths of a degree. This precision is pretty incredible since compasses didn't actually exist yet, and since 4,500 years ago, the North Star was in a completely different place. But finding north is actually pretty easy. Just watch where any star rises and sets during the night, and cut the angle in half.
That's hard.
Alright guys, so, this is where we're gonna participate. 1 finger is A, 2 is B, 3 is C, 4 is D. Okay guys? So, which of these statements are true, or do you agree with, right? What did this man say, alright? A, it was impossible to find north before the compass was invented, so ancient Egyptians really just made a lucky guess when they built the Great Pyramid. B, the Great Pyramid did not have a particular flat foundation. It was mostly crooked and uneven. C, the Great Pyramid was made up of 15,000 stone blocks and was 1,200 feet tall.
You said million something.
D, it's impressive that the Great Pyramid was closely aligned to the compass, since compasses hadn't been invented when it was built. Okay, tell me, A, B, C, or D? No. Yeah, which one? Yes.
It's either here. It's either C or D.
Okay, let's see. He just said it, right? He just said it. It is impressive at the Great Pyramid, so closely aligned to the compass, since compasses hadn't been invented when it was built. So the answer is D. Okay, what can we do? Are you serious?
It was
Are
like-
you just now telling me?
I'm serious.
This is what upsets me. I'm handing papers out of the door.
It was tardy.
Huh?
It was tardy.
No, don't respond. When I redirect,
After that, squaring the sides just requires measuring correctly.
quiet.
Pythagoras and his equation came way later, but ancient cultures like the Egyptians knew a 3-4-5 triangle made a 90-degree corner. They could even make a right angle with 2 circles. The line connecting the intersection of the arcs is perpendicular to a line through their centers. To level the base, some theories say the Egyptians used water-filled channels as natural levels. But this isn't likely when you consider how much water they have to carry in to keep it from evaporating. But if you can make a right angle, you can make a level. Put that on some legs and you can even level over long distances. When you think about it, a pyramid is just a bunch of stacked squares. So if you can master this measurement, you're most of the way there. Now we just need some stones.
Why is it not on the side?
Do I need to replay that?
No.
Yes. Yes, I'm gonna replay it.
Bruh.
Pay attention. Right?
After that, squaring the sides just requires measuring a right angle. Pythagoras and his equation came way later, but ancient cultures like the Egyptians knew a 3, 4, 5 triangle made a 90-degree corner. They could even make a right angle with 2 circles. The line connecting the intersection of the arcs is perpendicular to a line through their centers. To level the base, some theories say the Egyptians used water-filled channels as natural levels. But this isn't likely when you consider how much water they'd have to carry in to keep it from evaporating. But if you can make a right angle, you can make a level. Put that on some legs and you can even level over long distances. When you think about it, a pyramid is just a bunch of stacked squares. So if you can master this measurement, you're most of the way there. Now we just need some stones.
Okay, moving forward.
The Great Pyramid's core is made of more than 2 million blocks of rough yellow limestone. This is quarried right next to the pyramids, which is a big reason why they chose sites like Giza, where prehistoric oceans have deposited this building material right under their feet. They dig channels and pry these blocks right from the earth. The size of the block is actually determined by the natural thickness of these limestone layers. The evidence of these layers is the Sphinx, which was actually dug out of the earth, not built on top of it. These pyramids were originally covered with smooth white limestone from quarries up the Nile, which was stolen used in other buildings thousands of years ago. We found many chiseled stones used in these quarries, and the only metal Egyptians had access to was copper. That's a pretty soft metal, but when a slurry of sand and powdered rock is poured in as an abrasive, even copper tools can cut limestone.
All right, guys. So, read it, and then show me what answer. So, guys, not. What is not true? What is not true?
No, wait.
All right, show me 1, 2, 3, or 4. Show me. Show me, don't tell me.
No, it's three. It's three.
Quietly, I see 3s.
No, it's three.
Okay, thank you so much for participating, guys. Alright, thank you so much for participating. Alright, let's move forward.
To build the Great Pyramid, 203 blocks, an Olympic swimming pool's worth of stone had to be quarried every 8 days. That's a lot, but modern pyramid building experiments using technology available to ancient Egyptians calculate this amount of stone to be cut and moved by a quarry team of 12 to 1,500 workers, which is totally doable. Heavier stones, like the granite used in the pyramid's inner chambers, are much harder than limestone, They were literally chipped out by hand using heavy dolerite hammer stones, which we've also found a lot of. It would have taken a full day's pounding to chip away just a few centimeters, but then again, they didn't have Twitter to
Oh no.
All right.
Oh, it's
It's called egg.
It's true. No, wait. It's true.
Yeah, that's
All right, in 5, 4, 3, 2. All right. 1 and 2. The true and the false. All right, I am moving forward, people. Moving forward.
We found Egyptian boats large enough to have floated these stones down the Nile. How were 2 million blocks actually moved into place? It might be hard to believe, but wheels for transportation are a surprisingly recent invention. Not because making a round thing roll is hard to figure out, but because inventing a workable axle is. The oldest known rolling wheels on Earth date to before the Great Pyramid, but not again. Paintings tell us Egyptians used wooden sleds to move large objects, but they still had to deal with friction. Burying wood rails horizontally will allow a sled to slide more freely. The researchers at the University of Amsterdam showed in 2014 that sand has an interesting property. Wetting with the right amount of water makes it remarkably slick. A team of 10 workers can easily pull a 1-ton sled. But people always seem to forget that Egyptians had animals like donkeys and cattle around to help.
All right, guys. I'm not gonna help you with this one. So how did ancient Egyptians overcome friction? So how were they able to move those heavy stones? How were they able to move those heavy stones? No. You guys are supposed to be. I'm not gonna replay that.
Trust rubber.
If you're responding to the question, if you're talking, are you done, Daryl? Are you done?
Yeah.
Are you done responding to this question?
Yeah.
Because it's not just one answer. It's not just one answer. There's at least 2 answers to this. There's at least, no. There's at least 2 answers to this.
Bless you.
Bless you. He just wants to bless you. Go to y'all. Go to y'all. Who would say that? Who would say that? Who would say that?
I didn't.
Yeah, crust.
What?
Crust.
No, what?
Probably have a jar of it.
No, I don't. No, I don't. That's Coca-Cola. Alright, here we
I
go.
bet when you drink it, probably taste some crust.
Okay. And 5, 4, Daniel, you to go to the bathroom?
Yeah.
Make your quick one, fill that one.
Oh, no, I get it from over there.
No, go ahead, Jake. Okay. So, what I find,
See, man, that's the best
who are you talking to, Jorge?
Exactly.
Alright, what I find fascinating is that they knew geology. These ancient Egyptians knew those big pyramids. They knew that that it would be easier to build them in a place where the geology was perfect. You guys know what I mean by geology? So they knew
Physics.
they knew the ground and the rocks would be perfect for building those big pyramids. So it just so happens, did you guys hear that part where there was like ancient deposits there of perfect sand and rock? Okay.
No.
So they surveyed the land first. They knew this land is perfect where we can, the stones and the sand were already kind of like pre-made for them. I don't know if that makes sense. So there was that area where they built, you guys don't remember that? What they said?
I remember.
That area? Yeah, the ocean, like, so, that area was, stay after.
Be quiet, Alex.
No,
Okay.
sorry about
It was hidden right there.
Alright, so that whole area there where they built the big pyramids, the ground was perfect, right? They knew they could take advantage of that special sand, those special rocks that were already underneath there, okay? So, how did they know that? They must have been smart enough to know the geology of the land, okay? You just don't build a pyramid anywhere, right? It has to be the right place. You guys know that from doing the pyramid, the assignment on Friday, right? You guys knew that. That's why some of your pyramids were better than others, right? Okay, so here we go.
Oh, two. Constructing ramps to deliver stone must have been nearly as monumental as the pyramid itself. This is one place where there's no records of what they looked like. The researchers have examined lots of possibilities. An engineer named Craig Smith has done probably the most detailed ramp analysis, calculating how many stones could be delivered with each design, and he believed the Egyptians extended a big, wide ramp near the bottom, where a pyramid requires most of its stone, and then spiral ramps near the top, where fewer blocks were needed. Wooden letters and round dolerite ball bearings were used to guide stones into place, where they were carved to an exact fit. Joints between some of the few remaining smooth outer stones are so precise, you can't even slip a credit card between them. But digs have shown they weren't as careful with interior stones. It's a popular idea that the pyramids were built by slaves, but you shouldn't believe everything you see in movies. Egyptologists like Mark Lane uncovered enormous cities built to feed, house, and equip thousands of skilled workers with breweries, bakeries, tool shops. Signs that whole families lived nearby. Egyptian society at all levels dedicated themselves to what they viewed as the kingdom's proudest work. It's actually incredible to have as much evidence as we do about how the pyramids were built. But that doesn't mean building them was easy. In fact, it's the opposite. But difficult doesn't mean impossible.
Yeah.
What?
Okay.
Right in the back.
No, you're not answering this question. So, listen very carefully. So, I don't know if you guys, I'm gonna make you watch this again because
Why?
I want you to talk about, I want you to, no, let's just watch this. Okay, we're gonna,
Constructing ramps to deliver stone, it must have been nearly
okay. I want you to hear this last part, okay? You don't have to answer questions, just hear it again.
nearly as monumental as the itself. This is one place where there's no records of what they look like. The researchers have examined lots of possibilities. An engineer named Craig Smith has done probably the most detailed ramp analysis, calculating how many stones could be delivered with each design, and he believed the Egyptians extended a big, wide ramp near the bottom, where a pyramid requires most of its stone, and then spiral ramps near the top, where fewer blocks were needed. Wooden letters and round dolerite ball bearings were used to guide stones into place, where they were carved to an exact fit. Joints between some of the few remaining smooth outer stones are so precise, you can't even slip a credit card between them. But digs have shown they weren't as careful with interior stones. It's a popular idea that the pyramids were built by slaves, but you shouldn't believe everything you see in movies. Egyptologists like Mark Langer have uncovered enormous cities built to feed, house, and equip thousands of skilled workers with breweries, bakeries, tool shops, signs that whole families lived nearby. Egyptian society at all levels dedicated themselves to what they viewed as the kingdom's proudest work. It's actually pretty incredible that we have as much evidence as we do about how the pyramids were built. But that doesn't mean building them was easy. In fact, it's the opposite. But difficult doesn't mean impossible.
Skip it on it.
You have fun.
Yeah.
Go to
Get
the-
up.
Sadie,
Go to the-
go to the- I want you to go sit next to, Devin. Sadie, go sit next to Devin. All right, so, what is one thing that they use? It starts with an R. Lena, what do they use? Ramps. They use ramps, and they also, oh, yeah, they definitely, they use also ball bearings, right? You guys know what ball bearings are?
No.
Ball bearings? For ball bearings.
All bears.
Ball bearings. Bearings.
Bearings.
Bearings. Not earrings, not bearings.
Blueberries on my list.
Oh, okay, buddy.
Okay, Lily.
Okay, Valerie, can you freeze the screen?
I call him Bug.
I call Jaden the
I'm Freddy.
Where you look like
I know someone that does like this. I have tentacles.